developed a smart sensor that allows you to understand why exactly you're feeling too hot or too cold in your office or classroom, and at the same time enables building operators to make the building function much more efficiently. What our sensor does is it senses the surface temperatures and can thereby fully characterize exactly how that occupant is interacting with the thermal environment around them. The example of a classic cool radiant surface would be when you stand in front of that large plate glass window in the winter and you have that sensation of coolness. The thing that you feel is the rate of heat leaving your body more rapidly because you're radiating more heat to the cold window, and therefore your body perceives the temperature to be cooler even though the air temperature may be the same otherwise. So the SMART sensor, which stands for the Spherical Motion Average Radiant Temperature, moves in a spherical motion around a room, scanning all the temperature of the surfaces. On top of that, we're measuring the distance to all those occupants, because the other important factor is how far away those surfaces are from you. My sensor, similar to a thermal camera, uses a filter to filter out the visible light and allows us to then see the infrared emissions. But unlike an infrared camera that requires a very expensive germanium lens to do so across a large array, we use a single sensor that we then scan through the room in order to drastically reduce the cost of building such a sensor and make it appropriate for room scale deployment. Studies have shown that imparting thermal comfort on people by radiation eliminates problems like draft and variations in air temperature, which allows people to be more comfortable. The importance of the SMART sensor goes beyond simply making people happy and improving energy efficiency. We envision many opportunities to try and help address problems like urban heat island and heat stress on people in low-income environments, and the SMART sensor can help to define these metrics as well in order to improve our understanding of these economic and social challenges. We're envisioning various modes in which we can scale the size of the sensor down to something that would be able to be integrated into the sensor devices inside a thermostat. Ultimately, we hope to be able to stop just conditioning rooms and start to condition people to be comfortable.